All right, we are doing 5.3, present value of an annuity and amortization. The present value of an annuity, that is not a negative sign, just so you know. That's just letting you know that this is the formula. Okay. PV again stands for present value. So this is the thing to get to know. Present value means the amount we want right now. Payment is same as what we did in 5.2. Our R is our rate, N is the amount of compounds, and T is our time in years. So everything falls into place. I have an I in here. We're not using I, we're using R. We're using PV for present value, and we are using PMT for payment, which gives us more letters, but it makes a little more sense than having those other letters I just had on there. All right, so right now we have payments of $1,400. So this tells us that that's our PMT each year for 8 years, 6% compounded annually. Okay. Now, how are we going to distinguish this from the others? Well, the directions will say, and they're not written here, but the directions will tell you, hey, find the present value or find the amount now that would be there for payments of $1,400. Or if it wanted to be an ordinary annuity problem, then it'll say payments are at the end. So, so those are the two that'll two different items. Or they may just come out and say ordinary annuity or present value of ordinary annuity. So future value of ordinary annuity or present value of ordinary annuity. So they come out and tell you what it is. And like I said, I know I didn't find it here, but we're going to find out what the present value is. We want to know how much we would have to put down right now that would equal the payments of $1,400 each year for 8 years at 6% compounded annually. So we are trying to look for the present value. Okay, equals our PMT. I'm just going to write out the formula each time. 1 minus 1 plus R over N to the negative NT all over R over N. Okay, and so this is actually a modification of our formula that we had a few minutes ago for future value of ordinary annuity. Just a couple of things are a little bit different. Okay, so plugging our information in, we're trying to find our present value. We've got payments of $1,400. We're doing 1 minus our 1 plus our rate, which is 0.06, divided by 1, raised to the negative 1 times our time of 8 years. So again, I'd cross this off and I just write -8. So I don't have to worry about it. All over 0.06 divided by 1. So again, in doing our check figures, the check figures are what is going to be showing me work on your test. You will need parentheses here and here. You'll also need parentheses here and here. And so when you do that check figure, like I said, double check these check figures. Don't just say, oh, that's what she got, so it's got to be right. Okay, double check the check figures. So, and double check them each time that you work the problem. So you should have a check figure of 6.209793811. Okay. And like I told you, if you have a problem trying to get this check figure by typing the whole thing in, because you need those extra set of parentheses, otherwise you get something different. If you have trouble with it, you can do just the numerator, just the denominator, divide it, and you'll get to this check figure. All right, so our present value is equal to $8,693.71. So what does this mean? If we make payments of $1,400 each year for 8 years at 6% compounded annually, that's the same, going to produce the same amount as if we put in our present value and leave it alone at 8 years for 6% compounded annually. So we've got the same scenario, but this tells us how much we would have to put in now to produce the same thing as having those payments of $1,400 each year. And so that's what present value means, is how much do we need to put in right now? All right. This formula is a little more challenging than the others, but like I said, if you remember those extra parentheses and put those extra parentheses every single time, then you should be able to get the check figure and plug it into your calculator. All right, we are going to continue the present value formula just in a different form, and we're going to do it using amortization. So if you notice, this is your amortization. In most cases on amortization, you want to find out how much your monthly payment is. For instance, if you're doing a car, if you're doing a house, you know, or any type of loan that would require this, then this is the kind of formula that you would use. So it's the same thing, just a little modified. All right. This chart that I have down here, this is what we call an amortization schedule. We will be creating an amortization schedule, not this big. This one actually goes down to like 360 different payments or different periods. And so this is a pretty big one, but I wanted to show you how to read this. This information may not necessarily be given at the top, and we may have the items that I have listed here in a different order. We are not going to worry about escrow, so you don't have to worry about that. And we are not going to worry about additional payments. So those types of things. So ours is going to be just these first 5 that we have here. So for instance, if I wanted to find out what the 4th payment is. Okay. Now, normally, payment 1 is when you get the loan out. So normally we look at that. So if you see payment 1 and or payment 0, you'll just see the amount of the loan. So for the 4th payment, I will come down to my 4th period here. And then my payment, I would look across and it says loan payment. So I'm looking in my column and I'm looking in my row. And so that tells me that the 4th payment will be $135.10. And if you notice, all our payments are $135.10. Your payments should be the same every single time except for your very last payment. So that shouldn't be too bad of a read. Now, if I wanted to find out the interest paid in the first 3 payments, then I'm going to need to take my first interest payment, which is $19.38, and I'm going to need it to add to my second interest payment, which is $19.08, and I'm going to need to add that to my third payment, which is third interest payment of $18.78. So now, when I add these together, and I failed to add those ahead of time, so just a minute. So when I add these, I end up with the first 3 interest payments being $57.24. Now that's really not so bad, but in most cases, when you're taking out a loan and stuff, your interest payments are actually sometimes close to or a little bit higher than your principal payment. Okay. And so if you notice, our principal payments are a whole lot more here. Normally it's the other way around, where the principal payment is smaller and the interest payment is larger. So if you actually get a loan where your interest is this low, that is amazing. All right. And then okay. So the other thing that you may be asked is, how is the second payment used to reduce the debt? So in other words, they want to know, how is that second payment reducing your principal? Whenever they say the debt, they're talking about the principal. Okay. All right. And so in this case here, our principal payment is on the second one. It reduces the debt by $116.02. So again, it's making sure that you understand how it's read. Normally your remaining principal is written at the end. That's this column here, is normally at the end. We are going to be doing an amortization schedule, so you will see how the flow goes. This is just one that my uncle created and had for me when I first bought a house. No, I did not buy a house for $7,500. Played with it and changed the numbers and whatnot. So I just wanted to have this on there so that you understood how to read it. So like I told you, one of the things that you really want to know is you want to know how much payment, okay? The word amortize is your clue into using the formula for amortization. And again, that formula is going to be payment equals present value times R divided by N all over 1 minus 1 plus R over N raised to the negative NT. So this is the formula used for amortize. Like I said, you can use the present value of ordinary annuity. It's the same type. You just got to remember you're solving for the payment, not the present value. It works exactly the same way. So plugging in our information, we are trying to find the payment. So I'm not going to plug anything in there. So I've got payment equals present value. So that's the 7,400 times our rate of 0.095 divided by compounded monthly. So that means we're dealing with 12 all over 1 minus 1 plus 0.095 divided by 12 raised to the negative 12 times 10. Because again, we're doing this compounded monthly, so that's going to be our N. And got it for 10 years. Now with these problems, you can type it all in once, but again, I want those check figures. That's the key on this. And the main reason is that if you get something off, I want to be able to have something to piggyback on in order to give you partial credit. So this will be your payment. And in this case, you're going to have two check figures. You're going to have one at the top and one at the bottom. Okay, so do them individually, like I've been talking to you about. If you have trouble with them, you'd already be doing this. So your top number should be 58.58333, and that repeats on. All over. The bottom is going to give you 0.611, 809, 5902. Okay. Now, when you do this division in your calculator, on the top, don't stop after 3 threes. Make sure that you type in a bunch of threes, okay? Continue it all the way to the end. Do not round until your very last number, which would be the amount of your payment, okay? And then hit divided by, and again, get all these decimal places in there. So this tells us that our payment's going to be $95.75. So for a loan of $7,400, 9.5% compounded monthly, 10 years, we will have to pay $95.75 per month until the 10 years is done. A lot of banks these days will tell you that they don't charge for having you to pay off things early. And if you can pay off things early, that's better for you because then that's more money in your pocket and less interest to pay. So this is how we calculate the amortization payment. All right, so like I told you, we're going to make an amortization schedule of our first 4 payments. That's at most what you'll have to do on your test also. You won't have to do like 5 or 6 or 50 or 320. So you'll only be making 4 payments at most. And it says Joan Verosa plans to borrow $20,000 to stock her small boutique. She will repay the loan with semi-annual payments for 5 years at 7% compounded semi-annually. So she's borrowing the $20,000 right now. That tells us that this is our present value. Before I can set up a amortization schedule, I have to find out what this payment is going to be. These are the top titles of that amortization schedule. So in this case, I'm going to go ahead and I'm going to do my payment equals, using the same formula, 20,000 times our 0.07 divided by 2, because we're doing this semi-annually. So semi-annually means twice, all over 1 minus 1 plus 0.07 divided by 2 raised to the negative 2 times 5, or negative 10. Okay, so getting our check figures in there, we got our payment equals 700 over 0.29108 11863. Again, don't take my word on these check figures. Please double check me. Okay. So the payment should come up to be 2404.83. Okay. So we've got to figure out our payment first before we can set up our amortization schedule. So now when we do our amortization schedule, we have a payment number. We have our payment, which you can use the abbreviations. I'm good on this. And we have our interest. We have our portion. And we have our principal. Okay, so we're doing the first 4 payments. So we would have 0, 1, 2, 3, 4. So it looks like we're talking about 5 different payments, but we're going to the 4th payment. We have to have payment 0 on there. So payment 0 is not included in this first 4 payments. So payment 0, you will have dashes for everything. And the amount that's getting borrowed is what goes in the principal. So payment 0 does not count in the first 4 payments. All right, payment 0 has to be there because that's our starting balance. Now, for each of your payments, you're going to type in the amount of the payment that we got. So this is 2404.83, and we can go ahead and do that for our others and just get that taken care of because those will always match. Okay. To find out your interest, you're going to take your rate, your principal times your rate divided by the number of compounds. Your first principal is actually done for you because it is the very first number that you have at the top of your present value times your rate divided by n. So that's going to be $700. You can calculate it again by taking 20,000 times 0.07 divided by 2. You'll still get the same amount. To find your portion, you're going to take your payment minus your interest. So this will give us I got to double check a number. Hold on. Should give us 1704.83. So this is the amount that is going toward the principal. The interest never goes toward the principal. Okay, so 1704.83. Okay, to get your new principal for payment number 1, you're going to take your old principal of 20,000 and you're going to subtract the portion. Okay, or your previous principal. That way minus your portion. So in this case, we got 20,000 minus our portion. So that gives us $18,295.17. Everything in this chart gets written as dollars and cents, so you don't continue the decimal on in this chart. Just because in the real world, they don't have anything past our change. Now, to find the new interest rate, keep in mind all our payments are already filled in. So now I'm back to the second payment and I want to find out the interest. I'm not going to take 20,000 times 0.07 divided by 2. I'm going to take 18,295 and 17 cents, and I'm going to multiply that by 0.07 divided by 2. So this is going to give me $640.33. And so the interest rate should be going down, the portion amount should be going up. So to find our new portion amount, we're going to take the 18,295.17 and we are going to subtract the $640.33. No, sorry. To get the portion, you're taking your payment minus the interest amount. I was getting too big of a number and I couldn't figure out why. Minus 640. Okay, so that's going to give us $1,764.50. So if you notice, your payment amount or portion amount is going up, your interest amount is going down, which should happen every single time. Okay, now to get the new principal, this is what I was thinking ahead on, sorry. We're going to take our old principal, which is now the $18,000, and we're going to subtract the 1764.50. So I've got 18,295, 17 minus our portion. The numbers were wrong on my paper, so I have to rework this. So that gives us $16,530.67. And so now our new principal is this $16,000. It's no longer the 18,000. And so we start the process over again. So I take the 16,000 and multiply it by 0.07 divided by 2. My rate and my number of compounds do not change. So that's going to give us $578.57. To get my new portion, I'm taking 2404.83 minus 578.57. So that's going to give us $1,826.26. And then to do my new principal, I take my portion off of my principal. So I have 16,530.67 minus our portion. And so that gives us 14,704.41. And then just keep this process up as many times as you want to. But again, we stop at payment 4. So let me finish in payment 4. This should be $514.65. And then our portion should be $1,890.18. And that should leave us with a balance after the fourth payment of $12,814.23. Okay. This information that I gave you on how to find each one, the interest, the portion, and the principal, are not on your formula sheet. So you're going to have to learn how to how to manipulate this. But again, it's the same over and over and over again. So, it's the same process. So once you get the process, it just follows along each time. And that is it for 5.4, a little bit more challenging than 5.3. Even though we're only still dealing with one formula, we got two different ways that we can utilize it. And so if you have any questions, let me know. Email, come by and see me. And I hope you have a great day.